Greetings. Today we'll discuss breadth first search, which is one of the graph's traversal method. So here are the data structures. One is the parent, which stores the parent of a particular vertex. So here we record the parent of vertex 0. Here we record the parent of vertex 1. The other one is whether a particular vertex has been visited or not. So if a vertex is visited, then we say that this is true. If the vertex is not being visited, then we say that it is false. Okay. So the algorithm is like this. Step 1, it checks to see whether the queue is empty or not. If the queue is empty, the algorithm terminates. If the queue is not empty, then we remove or dequeue the front element from the queue, and then we process it, which involves to look at all the adjacent vertices. And if they are not visited, then we add it to the queue. After adding it to the queue, then it goes back to step 1, which is check to see if the queue is empty or not. Okay. So to start with, we start from vertex 0. So vertex 0 is added to the queue or enqueued, and it is set to being visited as true. Okay. So the algorithm begins to see if the queue is empty or not, step 1. Then in step 2, it is going to dequeue that vertex and process it. So processing involves to look at all the adjacent vertices to the one that is dequeued. So here we have 2, 3, and 4 as the adjacent vertices to 0. And all of them have not been visited. So we push 2, 3, and 4 into the queue. So first we push 2, then we push 3, then we push 4. And we set them as being visited. So we made them true. Okay. Then step 1, to see if the queue is empty or not. The queue is not empty, therefore we dequeue. So the front element is 2, therefore we dequeue that element here, and we process that. So we look at the adjacent vertices to 2, which is 0 and 1. 0 is already visited, 1 is still not visited, therefore we add 1 to the queue. Okay. And then we go back to step 1, which is check if queue is empty or not. Otherwise, we dequeue the first element from the queue, which is 3. Okay, and then look at all the adjacent vertices of 3, which is 1 and 0. Out of which 0 is already visited and 1 is also visited. So we do not add anything to the queue. Again, go back to step 1, see if queue is empty. Otherwise, dequeue the first front element in the queue, which is 4. So now we are processing 4. 0 is adjacent to 4, but it's already visited. So we do not push 0 into the or add 0, vertex 0 into the queue. So now step 1, again check to see if the queue is empty. Otherwise, dequeue the front element in the queue. Okay. Now process that particular vertex. It has 3 adjacent vertices, 2, 3, and 6. Okay. Out of which 2 and 3 are already visited. 6 is not visited. Therefore, we add 6 into the queue. There you go. Now we go back to step 1 to see if queue is empty or not. It is not empty. Therefore, we dequeue the front element, which is 6, vertex 6, process 6. So 6 has only 2 vertices that are adjacent, which is 1 and 5. But 1 is already visited. Only 5 is not visited. Therefore, add 5 into the queue. Okay, then go back to step 1, which is check to see if the queue is empty. queue is not empty, therefore we dequeue the front element, which is 5, vertex 5, process vertex 5. So vertex 5 has only one vertex, which is 6, as its adjacent vertice. Okay, so but it's already visited, so we cannot add 6 into the queue. Okay, so go back to step 1 and check whether the queue is empty or not. Queue is empty, therefore the algorithm terminates. So the order in which we have traversed the graph is 0, 2, 3, 4, 1, 6, and 5. Thank you.